Solving inequalities by inspection. The inequality 2x is less than negative 4 is shown on the number line. We can see that we have the blank circle at negative 4 and the arrow extending off to the left. And it's indicated here that we're doing this for 2x. Find values of x that are true for this inequality by completing the table below. So these are x values, these are 2x values. So this one here would be negative 8, then negative 6, negative 4, negative 2, 0, 2, and 4. Is 2x less than negative 4? Well, negative 8 is less than negative 4, and so is negative 6. Negative 4 is not less than negative 4, it's equal to negative 4. And then these are no's all the way up from there. Write an inequality to demonstrate what values x can take on and add this to the number line. Well, the boundary was when x was negative 2, because this was negative 4 and we said that was equal. So negative 2 just here, that's going to be the boundary. But when x was negative 3 and negative 4, those were okay, so the arrow would go this way. So it looks like x is less than negative 2. Do we get the same inequality as in b if we just divide both sides of 2x is less than negative 4 by 2? So we have 2x is less than negative 4. If we divide both sides by 2, we get x is less than negative 2, and that's true. That is the same inequality as we got in part B. The inequality negative 2x is greater than 2 is shown on the number line. Find values of x that are true for the inequality by completing the table below. So if x is negative 3, negative 2x would be 6. Then we'd get 4, 2, 0, negative 2, negative 4, negative 6. Are these greater than 2? Well, this one is, so is this one. This one isn't, because 2 is equal to 2. This one isn't, 0 is less than 2, and the same is true all the way along from there. Write an inequality to demonstrate what values x can take on and add this to the number line. Well, this one here was the boundary because 2 was equal to 2, and that looks like it's going to be true for negative 2 and negative 3, so it looks like that x would be less than negative 1. Do you get the same inequality as in b if you just divide both sides of negative 2x is greater than 2 by negative 2? So we have negative 2x is greater than 2, and if we just divide both sides by negative 2, this would give us x. This one would be negative 1, and this would be greater than. And no, we don't get the same, because this one is less than, and we can clearly see that's true from the table, and this one is greater than. So in the first example, where we divided both sides by a positive number, it worked, and here we divided both sides by a negative number, and it didn't. So let's explore that further. You're given the inequality 15 is less than 20. Is it true? Yes, it is. Divide both sides of the inequality by 5. So 3 would be less than 4. Is that still true? Yes. If the inequality is not true, well, it was true, so that's not applicable. We're given the inequality 12 is greater than 3. Is it true? Yes. Divide both sides of the inequality by negative 3. So 12 divided by negative 3 would be negative 4. 3 divided by negative 3 would be negative 1. giving us negative 4 is greater than negative 1. Is that true? No, it's not. If the inequality is not true, can we make it true by reversing the inequality sign? So that would mean negative 4 is less than negative 1, and that's true. You are given the inequality negative 6 is less than negative 2. Is it true? Well, yes it is. Negative 6 is further to the left on the number line than negative 2. Multiply both sides of the inequality by negative 2. So negative 6 times negative 2 would give me positive 12. Negative 2 times negative 2 gives me 4. So we have 12 is less than 4. Is that true? No, it's not. If the inequality is not true, can we make it true by reversing the inequality sign? Well, that would be 12 is greater than 4, and yes, that's true. We're given the inequality negative 1 is greater than negative 3. Is that true? Yes, it is. Multiply both sides of the inequality by 2, so that would give me negative 2 is more than negative 6. Is that true? Yes, and that means this is not applicable. What conclusion can we draw from what we've just done? Well, every time that we multiplied or divided by a positive, the inequality was okay. But if we multiplied or divided by a negative, then we needed to reverse. And this is an important point which you need to remember and make sure you use when working with inequalities. If you multiply or divide both sides by a positive, the inequality sign faces the correct way and you don't need to do anything. But if you multiply or divide by a negative number, then you're going to need to reverse the inequality sign.